Hey guys, a year ago we invited JJ from ASUS over to talk about Ivy Bridge, and here we are a year later, and he's brought a whole bunch of toys with him, and we're here to talk about Haswell. Now Haswell is a really unique platform because it's really very heavily mobile focused, but there's a whole bunch of innovation that continues to happen on the desktop, and ASUS is actually very committed to that. So just like last year, JJ is going to be here. This time he's going to actually be here with us for a couple of days, and we're going to go in greater depth to not only all of ASUS's new Haswell products, but some of the design decisions that they chose this round, as things are a bit different. We're going to go into greater depth on overclocking. We're even going to build a Haswell system with JJ's assistance. But for this initial video, I want to get started and one, get a feel from you guys what you think of Haswell, where it fits into your product stack, what your boards look like, and how you approach the design of your Haswell boards compared to previous designs.
Oh, that's a great starter. And first off, thank you for having me.
Yeah, no, thanks for coming.
So that's a really great question. I think that first and foremost, anytime that we approach a chipset launch, we look at it from two perspectives. One, taking a look at what the actual chipset and the CPU architecture is bringing to the table that's new, unique, and is going to be something new for our customers.
So what was that with Haswell? What's from your perspective, what's new and unique here?
Well, on the very basic level, right, you're going to have things such as the PCH has been upgraded, right? So a lot of guys that are interested in, let's say, SATA connectivity, you're going to get that bump up to go, hey, I'm going from 2 SATA 6G ports to 6, right? Okay. Or I'm getting more USB 3 ports. CPU.
So as a recap, how many 6 gig SATA ports do you get now?
We have 6 by default that are provided by the PCH. That are driven
off of the Intel controller. And how many USB 3 ports do you get?
6 also provided. So that's an update. You go from 2 on the previous generation on the SATA 6G side to now 6, and then same thing on USB 3, we went from 4 to 6. Okay. So those are nice updates, definitely all around. And then you also look at what does the CPU platform enable, right? Because that could, that in some degrees, could influence how you might go around developing the board design. One of the biggest changes, of course, where you talk about changes how this could affect the mobile segmentation is the inclusion now of the power delivery, or the IVR, as Intel's coined it, inside of the CPU.
This is what Intel's calling Fiverr, the fully integrated voltage regulator. So we've moved voltage regulation. It used to be, how did it work? You have all your rails that come in from the power supply, and then you had kind of in this area of the board, you split that into all the different rails you get to supply to PCI Express, the CPU cores, the uncore, all of that.
All that would be
on
driven
the board, and then that would get fed into the CPU. Now with Fiverr, there are only 2 inputs, right?
Correct.
So one heads into the main SoC complex and one is for memory.
That's correct.
And then the CPU itself takes that one voltage input. And what is that voltage input now? Approximately what voltage are we talking about?
Actually, I think it's actually closer to 1.9.
Okay, so you take this one input voltage. It goes into Intel's Fiverr, and then that splits out and does all the voltage regulation for everything. There's an individual rail that goes into the CPU cores, one for the uncore, one for the PCI Express controller, all of that. And it allows, from Intel's perspective, it allows them to kind of have greater granularity with creating voltage islands and having individual voltages set kind of more to what that particular island needs.
Yeah.
It also allows them to switch quicker between voltage levels, and that's Haswell is really the beginning of something major in that regard, right? Where Intel's trying to go away from or trying to approach this new philosophy of how quickly can we go between very high and very low performance states.
Correct.
And Fiverr really enables that. But on the motherboard side, that changes quite a bit for you guys, right?
To a degree. I mean, I think if you take a look at our board design philosophy, even in previous generations, we incorporated digital controllers. It was really trying to follow the ethos of what Intel was communicating to us in terms of the way that the architecture worked.
Interesting.
Even previously when we went and made the change from, let's say, an analog PWM system to a digital system, it was to improve on the transient response capabilities of what the platform would offer. And
so Intel has effectively been taking you down this path already, right? Saying, hey, we'll go from analog voltage regulation to digital, and then we just integrate it on die.
Correct. So I think that we've kind of always been following that trend of how can we continue to be as close as we can to that. And now it's just a question that it's inside the CPU package.
Yeah.
And for all intents and purposes, what we have to do is when we revisit the platform and we take a look at these changes, we have to figure out, what is it that the platform's actually now changed? Are there any consideration points at how we might have to tune certain aspects in terms of overclocking parameters that we defined, presets, algorithms, different things along those lines. And so, the main benefit ultimately is going to be for anybody that purchases the board. There's going to be maybe more consistency across the boards as a whole, in terms of maybe some of the management and the control functionality that's available to you.
And that's a trend that we've seen for a while now, right? It used to be that in order to get, the best overclocking, you needed, to spend the most possible amount of money on whatever your overclocking board was, in order to get that consistency. But one thing I remember us talking about last year is that you guys were trying to bring that consistency and that experience across the line.
100%, yeah, and that definitely hasn't changed. I mean, for us, first and foremost, is that we have kind of a set of non-negotiables that we're approaching the platform development with, and part of that is definitely an overclocking experience.
But this even works towards that, right? Where now that you guys focused on consistency across the board.
Yep.
Fiverr kind of
it helps. Yeah, exactly. It helps to bring even more consistency to that hoped achieved goal.
Gotcha.
of the most of the boards being able to have that same level of capability, at least in terms of what's driving it.
So one of my initial questions about this was, if you look around, the kind of CPU island on your board, there doesn't seem to be a visible reduction in component circuitry. Is
Correct.
that and as Intel integrates more, the kind of assumption is, well, everything
That's
should
just
get
too small,
off the board.
and mainly just because really, if we were talking about the space that's been saved, you're almost only talking about that PWM.
Okay.
So that space is pretty much almost not relevant to us from a motherboard design stage. It's not if it's all of a sudden Intel was saying, hey, we have the ability to have the inductor array be fully integrated inside the CPU package, and then that would fundamentally change the layout characteristic of what the motherboard would look like.
So users who are experienced with, let's say a Westmere, Linfield, Sandy Bridge, Ivy Bridge boards, their board layout isn't going to look very different. Despite the fact that this has been brought on package.
Yeah, I think actually to be very, very concise and clear, I think most users are going to see almost zero differential. If you've looked at one of our boards since the Sandy Bridge era, the overall look and feel and adjustment variables that are going to be present are going to be almost exactly the same. And part of that's come from that we've been leading that kind of digital push, that so many of the options that are even provided by the IVR had already kind of existed in our motherboard lineup. So for the most part, unless you're coming from a really, really older platform, it's not going to feel almost any different to you. It's just going to be a slight evolution in certain parameters as far as how you tweak and tune the platform.
Gotcha. And that's because even though Intel has kind of taken ownership of voltage regulation, you still have all the hooks to control those parameters.
Correct, yeah.
Got it.
Yeah.
So that's a big change with Haswell. What else is there?
For the most part, I mean, that's pretty much your key changes is really what we saw in the PCH, and then what we see there in the IVR. The rest is going to be very similar. You're still dealing with the same number of PCI Express lanes. You're still dealing with technically actually the same support in terms of the DRAM divider. There's been a quote unquote a slight bump up in terms of the maximum DRAM divider in terms of overclockability. But when you compare that to, let's say, the X79 chipset, which still exists in the marketplace as well, this is not going to be replacing in terms of the maximum or PCI lanes, or even in terms of the core, the cache count that's going to be available on the CPU itself. So you still are looking at this as pretty much a replacement for Z77 with an evolutional upgrade, really focused, I think, in storage. On the power side, it's a huge accomplishment in terms of what Intel has done at integrating that functionality, but to you guys as users, there's not going to be that much of a differential that comes into play.
Okay, and you bring up an interesting point. Intel continues to have this kind of bifurcated, desktop and really high-end desktop/workstation strategy where the Sandy Bridge E, Ivy Bridge E, X79, that platform continues to exist for the users who need the features that offers. And then for, I guess, the rest of us, there is Z77 and now Z87.
Yeah, definitely so. So I think kind of the next layer is that with these changes, how does that roll out and how does that fit within ASUS's lineup of motherboards?
Yes.
So we have actually 4 segmentational divisions within our motherboard group. So we have first and foremost this guy that you see right here, which actually has an entirely new color ID. Some of you guys would historically see this as our blue series boards, our main series boards. So this is now actually a new color ID with gold for our mainstream series.
So if you're used to ASUS, blue becomes gold. And that's where does that fit in the product stack?
Mainstream series is pretty much kind of where the ethos of where our kind of design focus comes into play. It's really about trying to take all the key hallmarks of what we hope to be present in any one of the segmentational boards, whether it's quality fan controls, advancements in the UEFI, integration of key technologies, whether it's like USB optimization, Intel NIC integration, all these kind of things like that are going to be consistently there. So this is pretty much kind of like the jack of all trades. It should be able to fit gamers. It should be able able to fit content creation. It should be able to fit everyday productivity, SMB and Soho. It doesn't really matter. We needed to kind of fit an overarching theme of being able to be a great platform, focus at reliability, performance, great functionality.
So if you don't fall into, let's say, a specific niche, then you go gold. This is the one you start with.
I would say yes, that's correct.
So within that family, what's your board stack within?
The board stack is pretty deep, actually. So this will be our largest mainstream board launch. So we've gone ahead and made an adjustment to the naming convention. So instead of having the hallmark kind of P8 in front of our model name,
yep.
You're going to start off with our Z87 Deluxe.
Okay.
Then you're going to move down to the Expert.
Okay.
Then you're going to move down to the Pro. And then you'll move down to the Plus, and then we're reinforcing a very strong value board in the Dash A. Okay. So that kind of makes up the core SKUs. We'll have a micro ATX SKU in the Z87-M, as well as, of course, you'll even have mini ITX-based solutions like we have here with the Dash I Deluxe.
Okay.
So that's what you'll see there. And pretty much, the thing that we want to hammer in on is that the quality and functionality you're going to have on any one of those boards is going to be very consistent, as well as going to be overclockability. So there's going to be maybe segmentational features within that board lineup that are going to be the differentiation as whether you get like a Pro versus a Deluxe. So an example might be Dual Deluxe is going to come included actually with an NFC box.
Okay.
That will allow you to go ahead and have accessibility to smartphones and tablets. Also come with an actual integrated 811 AC module.
Okay.
And you'll even have Thunderbolt, where let's say the Pro will actually be upgraded from previous generation to be dual band N with Bluetooth, but it won't have let's say Thunderbolt. So but it's not going to be a compromise that, let's say, the fan control functionality is going to be different.
So the non-negotiables are still the same. They all are going to have great overclockability. They'll all have the same amount of fan control and kind of accessibility in terms of settings.
Yes, and even in hardware spec, because there's things like the Intel NICs that we utilize, or let's say going.
So Intel NICs are top to bottom.
Except for when you go down to the Dash A. Dash A is going to be using a Realtek NIC, but where generally our banding starts off at, yes, we're going to continue to use that. We've even improved upon it. It's a new i-series Intel network controller versus the previous generations.
Okay, and so this is a huge step though for you guys to ditch that P8 modifier, right? Because that's a holdover from kind of like the old Pentium 5 days, right? Yes. When you first started doing Pentium 5 motherboards, they were all P5, whatever, and then you got to P6.
And we just kept kind of evolving. But, fourth generation core, so out with the out with the old, in with the new, right?
That makes sense. So that's your, what do I call that? Is that your gold series? Or
that's our mainstream series.
Your mainstream series. Okay, so that's mainstream. What else do you have?
Next up is going to be the Tough series.
Okay.
And
what does Tough do?
Tough is, it's really focused for users that are looking for longer generational builds. So you're not necessarily interested in building your system and rolling it over even with, let's say, a year, 2, 3 years. Okay. You generally have a focus of 3 to 5 years, hence the 5-year warranty that's offered on Tough Series boards.
Gotcha. So on mainstream, how long of a warranty do you have?
3-year warranty.
Okay.
You're also going to have more of a specific focus at advanced cooling and monitoring technologies. So you still get kind of all the same great design ethos of getting, fan control functionality, enhanced network connectivity, and improved storage performance, all that really good stuff, but with a real key focus at being about monitoring and cooling and extended reliability.
Interesting. So when you say extended reliability, even better component choice on the board?
Correct, and even additional validation. And for this generation, we've expanded it to a new micro ATX SKU as well.
Okay, so you'll have a Z87 ATX and micro ATX anymore?
No, for Tough, just those 2 SKUs.
Gotcha. And what's I see there's like all the shielding around the board itself. Mm-hmm. Is that purely visual, or are there other benefits to it?
No, we actually have quite a number of items here. So just a quick kind of recap here is this is the thermal armor system. So it utilizes kind of like a shunt design in place underneath the molded actually plastic that we have here. So it helps to direct air in specific areas that we'd like it to be.
Gotcha.
And we have a specialized kind of assist fans, one that helps to go across the VRM assembly, another one that there is kind of for the GPU zone. And we've even actually added a full backplate for this generation, which minimizes torsion and rigidity issues, especially if you have like big heat sinks that sometimes when you torque them in, they'll create a little bit of bend or bowing to the board.
Okay.
And this one will actually even serve as a heat sink to be able to conduct some of the heat away from the MOSFET assembly.
Cool. And that exists both on this and on your micro ATX
Yeah,
version?
the actual micro ATX version will be literally almost feature for feature exactly the same, just a small version of it.
Very cool. So that's Tough. And then this is your ROG.
Correct. And ROG is really focused always at kind of the I'd say the highest level of innovation for us when it comes to not only the hardware specification of what we incorporate, but where I'd say most of, let's say, our extensive development goes into trying new and different things on the board design. Because, of course, the adoption rate is the highest in terms of users saying, hey, I'm willing to get that board just for that one additional new feature.
Okay. In terms of warranty, are we at 3 year?
It's also 3 years, correct.
Okay.
But like most of the rest of the boards, they also do come included with our APS coverage. So that's an advanced warranty option.
Okay.
It's also included within the standard
and what does
warranty
that give
policy.
me?
That essentially allows you to RMA the board without having to send the board in for service.
So like an advanced RMA. Cool. So what do I get here? What's the main thing I get when I go ROG versus mainstream?
Well, ROG 1, of course, it's going to be the aesthetic. If you want to maybe pass that guy over to me, I'll give you a little bit of a visual identifier and a couple of things. So of course you get the red and the black look. The VRM components on all the boards are outstanding, but we kind of even take it to the next layer of really trying to justify that if you're getting a premium product, we add more.
Okay.
So an example that might be the capacitors here are going to be actually rated for 10K operation versus on our mainstream series, they're 5K, and the industry tends to use 2K.
Okay.
So you get an upgrade there. These, really high performance inductors that are, 60 amp rated. So that's a kind of a key hallmark on ROG. You're always getting an improvement in terms of the power delivery section.
So the folks that are really, really pushing the limits on overclocking, for example.
It's sometimes not even about pushing it to those limits. It's sometimes just about having that comfort and knowing that you have a higher quality specification on the board, right? Gotcha. In terms of some special add-ons that we've gone ahead and incorporated, we have actually a special accessory that will come included with the ROG board, specifically the Maximus 6 Extreme, but it will be compatible with all our ROG SKUs in the OC panel. So this is a really cool hardware-based controller that will serve the enthusiasts that want to kind of tweak and tune their system externally. But for guys that don't want to do that and want to drop it into a chassis, you'll actually be able to tilt this. We'll include an actual a 5.25 adapter. You slide it in, top mount into your chassis, and you can adjust things like your CPU fan control. You can have a quick OC profile. You can go ahead and see your temperatures and voltages, all in a kind of like a fan bay kind of controller implementation. And so we think that's a really nice choice. There also will be an exclusive set of software and UEFI options for the board, things like an integrated RAM disk. Even secure erase will be built into the UEFI for ROG series motherboards.
Oh, very cool. So you'll be able to secure erase SSDs.
Yeah.
So I need this. Can I have this?
It's awesome. Plus there will be some very advanced sound software features such as Sound Radar, which will be a dynamic way of detecting in-game audio and visually showing it to you on a screen where it's coming from. So 2 additional points actually to round out ROG are going to be, one, we noted on the Sound Radar implementation, so going along with that is we're keeping our advanced isolated Supreme Effects audio design, where we're fully isolating the actual PHY audio codec, which is the ALC 1150, on all of our ROG series motherboards minus the Extreme series. So that's going to go ahead and help us to maximize audio performance, give you overall an improvement in gain as well, so it'll sound louder, and overall just give you a better integrated sound experience.
So here you're physically separating PCB layers.
Correct, yeah. And there's some additional aspects too, such as improvements to the capacitors. We're specifically putting on board audio-centric capacitors, and we're also shielding the codec itself. So overall, some improvements in terms of giving you a better onboard sound experience. And in addition to that, the boards will feature actually an M combo module, with the exception of our Hero board, which is a more value-oriented ROG SKU. Will give you the flexibility of having Wi-Fi support, as well as support for a new specification for flash storage, which some people have called NGFF, or has been finalized as M.2. I think the last one here is our WS segmentation. And so WS is really kind of focused at the community that's interested in content creation, productivity, kind of SMB Soho space, but also kind of straddles some lines for guys that are just interested in sometimes having better support for maximum expansion and connectivity. So key hallmarks tend to be here is things like Xeon support, ECC memory, enhanced option ROM validation for complex cards like, let's say like a RAID controller, or a quad gigabit network card, maybe running multiple HDMI capture cards, things along those lines.
Gotcha.
Plus, you tend to have a lot more PCI connectivity on the board, and almost mandatory is dual NICs on the board as well.
Cool. Well, that rounds up ASUS's entire, I guess, the high-level overview of ASUS's Haswell lineup. JJ, you're going to stick around for a couple of days here. We're going to go through overclocking. We're going to build one of these systems ourselves and go through your new UEFI and software suites. So stay tuned.